Okay, amides is a carboxylic acid derivative wherein the hydroxyl group has been replaced by an amino group. Okay, so if we could still remember, carboxylic acid will have RC double bond O OH, but this time, being an amide, the hydroxyl part of the acid will be replaced by an amino group NH2. Hence, the general structure of an amide is RC double bond O NH2, or that could be RCO NH2. Okay, so this carboxylic acid could react with an ammonia, that is the NH3, to form the amide. So the mechanism is you have the carboxylic acid and then you have the ammonia, one hydrogen from the ammonia and the hydroxyl from the carboxylic acid will join to form water. So that would be the water. Nandito kasi yun eh. Water. And then the remaining part of the carboxylic acid and the ammonia will bind together to form the amide. So this is the acid part and this is the ammonia part. Nevertheless, the whole structure is amide. We have classification of amide: primary, secondary, and tertiary. Okay, for it to be a primary amide, okay, it will follow the structure RC double bond O NH2, wherein the amino group, the nitrogen particularly, will be bonded to two hydrogen. And this is called unsubstituted amides kasi walang naka-attach na substituent sa amide group. Okay? So always bear in mind, for it to be a primary, the nitrogen in the amide part of the, or in the amino part rather, of the amide group of, or the amide classification, has no other carbon atoms. Rather, two hydrogens are bonded to that. For it to be a secondary amide, the amino group, or the nitrogen in that amino group, is bonded to one substituent, and that it is bearing only one hydrogen. Okay? Hence, the secondary amide is known as monosubstituted amide because there is now the presence of one substituent being attached to the nitrogen. Okay? So, ulitin natin, primary amide, the amino group doesn't have any carbon atoms attached to it aside, of course, from the carbonyl group, and that it is having two hydrogen. For it to be secondary amide, the amino group is bonded, of course, to the carbonyl group and another series of carbon atom, and it should only bear one hydrogen. For it to be tertiary amide, the nitrogen in the amino group should be bonded to two other substituents and a carboxyl group. And this time, no hydrogen could be found being attached to the nitrogen. So as you could see, the nitrogen, the bond requirement for nitrogen is 3. It should always bear 3 bonds. Okay? Unlike for carbon atom na 4 bond requirement, for nitrogen, 3 bond requirement lang. So recap, primary amide, the nitrogen will have 2 hydrogens. For secondary amide, the nitrogen will have 1 hydrogen. And for the tertiary amide, the nitrogen will no longer bear any hydrogen. And also, the tertiary amide is known as disubstituted amide. Disubstituted kasi may dalawang substituent na naka-attach kay nitrogen. For the nomenclature of amides, okay, we have common names and IUPAC name. We just have to know the name of the carboxylic acid that is present in the amide. Have that IC acid or the OIC acid be changed to amide. Say for example, if the acid part in the amide is benzoic acid. We drop the OIC acid and add the amide suffix, hence it will now become a benzamide. Okay, another example. So this is an example of amide. It has C double bond O and H2. As you could see, isa lang ang carbon atom, so therefore it will adopt the meth. Originally, this is methanoic acid, but since hydroxyl has been replaced by an amino group, therefore we drop the OIC acid. So if that is methanoic acid, we are dropping the OIC acid and add the suffix amide. Hence, that would be methanamide. Okay? And this methanoic acid has a common name, formic acid. So originally, formic acid siya. But as a rule, we are dropping the IC acid for the common name and affix the suffix amide. So therefore, the common name is formamide. Okay, so yung rule number 1, sinasabi lang niya, get the carboxylic acid, drop the IC acid or the OIC acid, and then add amide. Okay, next would be, this is an ethanoic acid originally, but because of the amino group, it falls under amide, so therefore, parent chain will have 2 carbon atoms, so that would be ethanoic acid. But we are dropping the OIC acid and affixing amide, so therefore that will have a name ethanamide. Ethanoic acid has a common name of acetic acid, but we are dropping the IC acid and we affix the amide, so therefore this structure will have a common name of acetanamide. So ethanamide and acetanamide are just the same. Okay? And then, next would be propanamide. Prop stands for 3 carbon atoms. So, ito yung 3 carbon atoms na yan. And then, the amide is a suffix to denote that this structure will fall under the group of amide. Originally, the parent chain or the acid name here, the original acid's name is propanoic acid, dropping the OIC acid and adding amide. So therefore, that is propanamide. And it will have a common name of propionamide. Okay. Rule number 2. Before we proceed to rule number 2, we have example. So choose the parent chain that contains the carbonyl group as well as the nitrogen. So ang hahanapin natin na kasama dun sa parent chain ay carbon atom that bears the double bond O and the amino group. So, dapat palaging kasama yan sa counting or sa parent chain. And that would be carbon number 1. Okay? Then, kunin natin yung straight chain. This one will have 4 carbon atoms. So, originally, that is from butanoic acid. But we have to drop the OIC acid and affix amide. So, therefore, the parent chain is butanamide. Okay, common name is butyramide. Okay, because it is the common name for butanoic acid is butyric acid. Okay? So, ang hindi na isama dito sa butanamide is this substituent. And the identity is methyl. So, we have methyl there. Meth means 1. And this is attached on carbon number 3, having the carbonyl carbon to be carbon number 1. So, laging tatandaan, itong carbonyl atom na to ay ang carbon number 1. So, the IUPAC name will be 3-methylbutanamide. But having its common name, we know that the second carbon atom is the alpha and the third carbon atom is the beta. Therefore, the common name for this structure is beta-methylbutanamide. Okay, another example. Choose the parent chain. And the parent chain are a series of carbon atom that contains the carbonyl or the carbon atom that bears the carbonyl and the amino group. So this is our parent chain. It has 3 carbon atoms, so that is propanamide. Okay, what is not included in propanamide are substituents CH3 and Cl. Numbering it with carbonyl as carbon number 1, this substituent is attached on carbon number 2. Therefore, the IUPAC name is 2-chloro-2-methylpropanamide. 2-chloro means that the carbon atom is attached on the second, the chlorine atom is attached on the second carbon atom. Same is true for the methyl group to be attached on the second carbon atom of the parent chain propanamide. Okay, so still we follow the rules that we have to use dashes to separate word from a number, and this name of the substituent should be arranged alphabetically. Okay, and here the common name for this is alpha chloro alpha methyl propionamide. The alpha should be separated from the name of the substituent because these Greek letters are serving as a locants or locator for this substituent. So, ang purpose niya ay to indicate a position. So, therefore, parang it is representing a number. So, therefore, a dashes should be used to separate them from the name of the substituent. Okay? And then we have rule number 3. If there are, okay, going back, if there are now substituents attached on the nitrogen, how are we going to name them? Okay, so originally this is our parent chain. It contains the carbon atom that bears the carbonyl and the amino group, and it has 3 carbon atoms, so that is propanamide. However, the substituent is no longer attached to the propanamide carbon atom, rather to the naka-attach na ngayon tong substituent dun sa nitrogen. So to locate the position of this amino of this substituent, we are going to use N as a locator to indicate that this substituent is attached to the nitrogen and not on the carbon atoms. So that would be Nmethylpropanamide. Take note that we are using a dash to separate the locant N and the substituent because N, kahit na hindi siya, even though it's not a number, it is serving as a locator, so therefore, we are going to separate it from the name of the substituent with the use of a dash. Okay. Next one here is, so the parent chain here will bear the carbon atom that bears the carbonyl and the nitrogen. And eventually there are two carbon atoms here. So that is ethanamide. Ang ating mga substituents ay methyl group. And eventually they are attached on the nitrogen. So, hindi tayo gagamit. We are not going to use a number. We are not going to use a Greek letter. Rather, we are going to use N as a locant because these substituents are attached on the nitrogen group. Therefore, the name of this structure is Nn-dimethylethanamide. Nn stands for the locant for these two substituents. Okay, dimethyl, because there are two same methyl groups attached on ethanamide. Okay, and the common name here is Nn-dimethylacetanamide. Okay, and then the last rule, so the simplest aromatic amide is known as benzamide. Okay, so originally it is a benzoic acid, but the hydroxyl group has been replaced by an amino group. So we are adapting the benzoic acid but dropping the OIC acid and adding the amide. Hence, this would be benzamide. Okay, so this functional group C double bond O NH2 will always assume carbon number 1 on the benzene ring. So we have to number the ring either clockwise or counterclockwise for as long as we have come up with the lowest number for the first encountered substituent. So therefore, the name of this structure is 2-methylbenzamide kasi yung 2-methyl. This is attached on carbon number 2. Okay? For this case, this is Nmethylbenzamide. This is the benzamide, and eventually, on the nitrogen, may naka-attach na amino group. And we all know that we have to use N as a locator if the substituent is attached on the nitrogen and not on the carbon atom. So therefore, this is N-methylbenzamide.